So we're supposed to do cosine minus 1 times cosine plus 1. So I'm going to put a little note on here. This is called the difference of squares. Note, if you ever have something that looks like a minus b and a plus b, you don't have to do the full distributing. This is just going to equal a squared minus b squared. All right, it's just a squared minus b squared. So in this case, my cosine alpha is my a value, and my 1 is my b value. So I don't have to use FOIL or anything. We're just going to say this is the same thing as cosine squared alpha minus 1 squared, which is really just 1. So now we have cosine squared minus 1. I strongly encourage you to do what I'm going to do next versus trying to do this in your head. Anytime you have cosine squared or sine squared, what I typically do is I go to the other side and I just write, well, sine squared plus cosine squared equals 1. And then I'm going to try to replicate this. I'm going to try to replicate this. I want cosine squared minus 1 on one side here. So in order to do that, I would need to subtract 1 from this side, which would give me sine squared plus cosine squared minus 1 equals 0. Then I would subtract sine from both sides and give me cosine squared minus 1 equals sine squared. Yeah. And now we're going to take that negative sine squared, and you can actually plug that in place of that, because that is the exact same thing. Cosine squared minus 1 squared, or 1, equals negative sine squared. So our end answer is going to be just negative sine squared alpha. Negative sine squared alpha, which would be C. So my hope is, and it seemed like it was the majority, it was like 11, 6, 2. Your goal should be one of these two. You just have to make sure it's negative or positive. So these should have been the major ones. Cosine squared would never have worked because we had that 1 there. You can't just make that 1 disappear without changing it to sine squared. All right, questions on that? All right, questions on the homework? Jacob. 11. 11 is actually this exact same problem. It is, we have 1 minus sine of x times 1 minus sine of x. Well, that's a minus b, a plus b. That should have been a plus, right? Yeah. So that's just going to be your a value squared, so that's 1 squared, minus your b value, so that's minus sine squared x. This is one more of those cases where you write sine squared plus cosine squared equals 1. To get sine squared minus 1, we'd have to subtract sine from both sides. So you'd have cosine squared equals 1 minus sine squared. This is just to help me. So now I can recognize that it's 1 minus sine squared equals cosine squared, so we just plug cosine squared in that place. And you just have that equals cosine squared x. That's why I had that note down there, because I do that. I'll do that almost every single time on those. All right, other questions? Tasha? 15. All right, 15 gives us 1 plus cosine alpha, tangent alpha, cosecant alpha over cosecant alpha. Now, we were supposed to change everything into terms of sine and cosine. So I need to change that tangent, that cosecant, and that other cosecant. And it's going to look something like this. So it's going to look like that, because I needed to replace tangent. So I replaced that tangent with sine over cosine. I replaced that cosecant on the top with 1 over sine. And finally, I replaced that cosecant on the bottom with 1 over sine as well. So your goal is just to replace everything. Yeah?
Make it simpler. Could you just get rid of the cosecant, both of them right away?
No. Like, these will not cancel out. And they won't cancel out because there's an addition here.
Wait, where?
Are you saying cancel out this and this?
Yeah.
They don't cancel out because there's 1 plus here.
Okay.
This is actually 1 over cosecant plus all of this over cosecant. So you could have rewritten as that. So this is actually 1 over cosecant plus all of that other stuff. I'm not going to write it all over cosecant. So it could cross out in that fraction. Okay. But anytime you have addition, you can't just subtract it from the top and bottom. That only works if it's just like that. Now it's cancel out because it's all multiplication. But this addition holds that there, basically. All right, so I changed this to sine over cosine, this to 1 over sine. I changed my denominator to 1 over sine. Well, sine and sine cancel out. Cosine, this is actually cosine over 1. Cosine and cosine turn to 1. And we're just left with the 1. So we have 1 plus 1. That's what I have here. 1 plus 1 over sine, which equals 2 on top, times, flip it, keep, change, flip, keep the top, 2, change the sign to multiplication, and flip the bottom, so it's sine over, so it's just 2 times sine of alpha. Other questions? Okay. And then we'll go into today's. Today's is, we've already done kind of what we are going to do today. There were times where I said find cosine alpha, given that sine alpha equals 3 over 5. And you're in quadrant 2. So your first step was always, well, if I'm in quadrant 2, all students, that means sine is positive, cosine would be negative. So that's what I'd be thinking as I read this. Quadrant 2 just means that cosine would be negative when I get my answer. Then we use the fact that sine squared plus cosine squared equals 1. And since I knew sine alpha was 3 over 5, we just have 3 over 5 squared, don't forget about the squaring, plus cosine squared equals 1. And then we just had to solve for cosine. And we came up with a plus or minus, but we already knew cosine needed to be negative. That's why our final answer is negative 4 over 5. Well, we're going to do the same thing, but with other trig identities. In fact, we're going to find all 6 of them given 1 bit of information. So that is our first problem. It says, given that tangent alpha equals negative 2 over 3, and alpha is in quadrant 4. In quadrant 4, we have all students take calculus. So in quadrant 4, our cosine is positive, which means our secant is positive. Everything else is negative. So we have cosine is positive. That is positive. Yeah, I just put all others negative. Find all the values of the other trig functions by using identities. So we need to find all 6. The easiest way to start this off is just find your reciprocal one first. So you were given tangent, so the first value you're going to find is cotangent, because cotangent is just the reciprocal. So your cotangent is going to be that first value you find. The cotangent of alpha is just the reciprocal of tangent, so that's going to be negative 3 over 2. And we're done with one of them. Now we just have 4 more to go. All right, so now we're going to use another trig identity to get it, and we'll look at what information we're given. We're given tangent, so you're going to pick one of your identities that has tangent in it, and one of the squared ones. The ones that come from sine squared plus cosine squared equals 1. So look at your identity sheet. Look at your Pythagorean identities. Look at your major ones. Find the one that has tangent in it. Just the top three, not all those variations. You're just looking at those top three. You're looking for the one that has tangent in it. And hopefully you're looking at the one that's that secant squared equals tangent squared plus 1. And all we're going to do is we're going to write that down. So we have secant squared alpha equals tangent squared alpha plus 1. You don't have to do this, but it can be helpful for some people. Remember that this is actually saying secant alpha squared equals tangent alpha squared plus 1. Now you can take your tangent value and plug it in for that tangent value there. And so we're going to have secant alpha squared equals that negative 2 over 3 squared plus 1. Well, this is just solving. We'll have that secant alpha, that says C, secant alpha squared equals, well, negative 2 squared is 4 over 9 plus 9 over 9. 3.
Do we have to memorize these all for a test? Or are we going to have like a half sheet?
You will not have a half sheet for the test. You have to have it memorized. Like I said, I can just give you a quiz. Because all you need to really know is sine squared plus cosine squared equals 1. Divide everything by cosine and divide everything by sine. So you could have it, you can actually develop those. That's what we did on day 1. But yes, on Thursday you could have a quiz on all of these, that you have to know all of them. Because it really isn't that much. All right, so continuing on, we have secant alpha squared equals 15 over 9. We would just take the square root of both sides. And so we are going to have secant alpha equals the square root of 15.
It's 13.
Oh, it's 13. Yeah. Over the square root of 9, which is 3. And it's either plus or minus. So it's either plus or minus. You look back up here. Secant needs to be positive, so this is going to be a positive. Once I get secant, we're going to go ahead and get cosine. So since my secant equals that, my cosine alpha is going to equal the reciprocal, which is going to be a positive 3 over square root of 13. I need to multiply the top and bottom by square root of 13. And so my cosine alpha is actually going to equal a positive 3 square root of 13 over 13. All right, now we have to use another identity because we ran through this one. We got our secant squared, which got us our cosine. Since I have my cosine, I'm going to go ahead and get my sine by using cosine squared plus sine squared equals 1. So remember, we have our cosine squared alpha plus sine squared alpha equals 1. My advice to you is pick the easier of the ones. Because remember, we do have to square this. So it'd be hard to square this one. So I'm going to take this simpler fraction. This one's a little bit of a simpler fraction. I'm going to take this one and plug it in for my cosine. So I'm going to take kind of that easier one, that 3 squared, and plug it in for that cosine value there. It's just a little easier to square. All right, so we're going to have 3 over square root of 13 squared plus sine squared alpha equals 1. All right, now we square it, so I'll have 9 over 13 plus sine squared alpha equals, I'm going to change that 1 to a 13 over 13. Because our next step is to subtract 9 over 13 from both sides. And we are just going to have sine squared alpha equals 13 minus 9 is 4 over 13. Take the square root of both sides. And we are going to have sine alpha equals square root of 4 is 2 over square root of 13. And it is either plus or minus. So you have to look up here. It's not secant. It's not cosine. All others are negative. So that's going to be a negative 2 over square root of 13, which reduces down to negative 2 square root of 13 over 13 when you simplify. And our final one is just cosecant. It's just reciprocal, so it's going to be negative square root of 13 over 2. All right, so the only thing we added, we're now running this through two different trig identities. And in short, really, you just have to find two. You're really just finding two, because we just had to find secant, and cosine was just reciprocal. Then I just had to find sine, and then just find the reciprocal. So these are longer problems. They're worth a lot of points. Just take your time on them. Take your time on them, especially on the test. All right, questions on that? So we're just using identities. All right, the next thing we're going to talk about is using even-odd identities. That is the last thing on your identity sheet that now allows me to give you a quiz anytime I want to, because I talked about all the other ones. The top ones are your reciprocal. Can I borrow this real quick? Your top ones are your reciprocal. Your quotient, we already talked about. Today we're talking about odd, even. And the Pythagorean ones, you just need to know the three. You just need to know the three. You don't need to know the variations. All right, so if I gave you a quiz, it would look like this, pretty much blank. I would have like sine x equals, cosine equals, tangent equals kind of thing. But for the Pythagoreans, you just need to know the top three. All right, so this gets us into our using even-odd identities. Now, even-odd identities come down to where things are positive and negative on our unit circle. It's all students take calculus. Since cosine is positive on your right side of unit circle and negative on the unit circle, if you look at any one of these values, if I find cosine of 60 degrees, that's a positive 1/2. If I find cosine of negative 60 degrees, it is 1/2 as well. And that works for any cosine value. If you look at the cosine value of 135, that's negative square root of 2 over 2. If you do cosine of negative 135, it is also negative square root of 2 over 2. So that means if you have a cosine of a negative x, you can actually rewrite that as cosine of positive x. That means if our cosine of negative x equals cosine of a positive x, that also works for secant because it's just the reciprocal. So if you ever have a negative side in your secant, you can get rid of the negative sign and just make it positive. And that is because your cosines are positive and negative lined up. For sine and tangent, it doesn't work that way. Sine and tangent, it doesn't work that way. If you look at the sine of 30 degrees, it equals 1/2. If you take the sine of negative 30, it equals a negative 1/2. So what you can do with that negative side inside the parentheses is you can actually throw it out front to help you solve the problem. So sine of negative x actually equals negative sine of x. Those two things will result in the exact same value. So that means in our odd even identity thing, sine of negative x equals negative sine of x. And the rule still applies to cosecant because it's just a reciprocal. So cosecant x, quantity, negative. Sine and tangent share that same fact, that you pull out the negative sign. So tangent of negative x would be negative tangent x. And cotangent would be negative cotangent x. So cosine is the only one you can change to positive. Cosine and secant. All the rest of one, you have to pull the negative sign out front to rewrite it. All right, an example of this. It says simplify the sign of negative x cotangent negative x. None of our identities have negatives in them. That's why we have to use this odd even thing to pull our negatives out or to get rid of them all completely. So sine of negative x, you'd pull that negative out front. And you do the same thing for your cotangent. So if I was to rewrite this, we would have negative sine of x times negative cotangent of x. Well, negative times a negative is a positive. So we'd actually have positive sine of x times cotangent of x. Now we can use other identities to help us solve this. So if I have sine here, I probably want to change that cotangent in terms of sine. Sine and cosine. So I'm going to rewrite cotangent. And since it's cotangent, I'm going to put cosine on top, sine on bottom. So it's sine of x times cosine of x over sine of x. That's one of those identities you need to have memorized. Now your sine values just cancel out, and you're just left with that equals cosine x. All right, the last thing we're going to do is something we're not going to do a ton of. It is proving that an equation is not an identity. These can be tedious, really hard, and time-consuming, and don't really show me that you know stuff. All right, so we won't do much of this, but I do need to show you how to do it. So proving that an equation is not an identity. It's easy to prove things are identities because you can just go through all your identity sheets and see if you can get there. And if I say prove it's an identity, it is true, and you'll be able to get there. Proving that something is not an identity is a lot more difficult. Because what you need to do for an identity, to be an identity, it must be true for any value of x. What you need to do is find any one value that is not true. So in short, you're just plugging in values and hoping one of them isn't true. Because some of these, it could just be one value that doesn't work, and it makes it false. So this is basically trial and error, plugging stuff in and seeing if it's true or false. So in this case, I'm going to pick completely randomly. I'm going to let t equal, I think almost anything works, but I just picked pi over 4. Most angles would actually work. So this was just a random pick. All right, that's just a random angle, i.e. trial and error.
So it's gotta be an angle, you can't just be like 2 or something? Like,
An angle's nice because we can use the unit circle.
oh, okay.
And we know sine exists at pi over 4. If you pick something that it doesn't exist at or something, or it's harder to find, if you have your calculator, then you could pick 2. But if you don't have your calculator, pick an angle that's on our unit circle. So in this case, we're going to check both of them. So this is kind of our check. So we're going to check sine of 2a first, or 2t. Well, if I plug pi over 4 in for that t, we are going to have sine of 2 times pi over 4, which is going to be sine of pi over 2. Well, pi over 2 is straight up, and it's at 0.01, so our sine value actually equals 1. Sine of pi over 2 just equals 1. All right, now we're going to check the 2 sine of t. So we have 2 sine of t. Once again, you're going to replace your t value with that pi over 4. And we're going to have 2 times sine of pi over 4. Well, pi over 4 is that middle tick mark, where sine is square root of 2 over 2. So this is going to be 2 times square root of 2 over 2, which just equals square root of 2. 1 does not equal square root of 2, so that's how we proved it was false. Those two things are not true. Yes?
What if you chose like a different angle?
Some might work. If I ever ask you to prove it's not true, you just know it's not true.
Okay.
So if you pick an angle and it turns out it's true, pick another angle.
Okay.
Generally speaking, if I pick one, most of them are not going to work. There may be 1 or 2 that work, so just pick another one,
Okay.
up or down kind of thing. The big errors kind of come at pi over 4, because the cosine and sines are always the same, and at pi over 2.
Okay.
All right. So if one doesn't work, just go 1 to the next one. So if pi over 4 didn't work, use pi over 6.
Please try again in a moment.
Can someone turn off their phone?
Yeah, I don't know why that happened.
Because your phone's on?
Yeah, no, I don't know why that went off though.
Because your phone's on?
Oh,